Hi everyone. We are the team, the Machinists, and we are excited to introduce our high-performance disaster rescue robot. I'm Ankit, and I have been working on the project's submarine design, and I have also developed the concepts of reinforcement learning so that the robot can navigate on its own in the difficult land territories. My teammate, Bisheyshwor Acharya, has been working on the robot's main body structure and the drone design. So he has also done the performance analysis on this robot. So together we have created a robot that can be used in disaster zones, and this is used and aimed at saving lives and making rescue operations much safer and faster. Now let us begin with the mobility and terrain navigation system that is present in our robot. So our robot is equipped with terrain adaptability features. We have the drones that can traverse across the air, we have the submarine that can traverse across water, and we have the general body with strong traits that can traverse across difficult slippery situations through mud, through flooded areas, and through debris. So the trays provide traction in slippery conditions so that the robot does not slip, while the propellers enables efficient movement through water. The propellers are of amphibious types. That means they can be used as a wheel in land and as a propeller in water. Our robot also has an obstacle handling features. The first obstacle handling feature that we have incorporated in our robot is the extendable arms or extendable legs. These legs are able to clear the those obstructions up to 25 centimeters, because generally we have observed that 25 centimeters is the general level of obstructions in these areas. If it has to cover more obstructions, or if larger obstructions arises, the robot is able to navigate through those circumstances through its 6 degree of freedom arms that have saws, that have drills, and that have other equipment, so that it can remove those obstructions from the area of travel. The speed and efficiency of the robot is well thought out. It is basically 10 kilometers per hour in land when traveling straight. The submarine achieves higher speed in water, while the drone navigation system is designed to be in general the same capability as that of the general mobility drones that we see. Because it is able to travel in land, it is able to travel in air, and it is able to travel through water. We can think of it as a swarm of robot system, in which one robot communicates with the other to function. Now we move on to search and detection subsystems. So search and detection subsystems is primarily accompanied with sensor technologies. So in sensor technologies, we have used thermal sensors, infrared sensors, ultrasonic sensors, and sound sensors. So in thermal sensors, we detect heat signatures from humans or animals. So these heat signatures are fed to AI or machine learning algorithms, and the machine learning algorithm detects this special kind of heat signatures that are of humans or animals. So these can be used in low visibility areas where the debris or the sand concentration is high, or the humidity is high. We have also infrared sensors, and infrared sensors identify temperature difference in the environment. And due to identification of temperature environment, it is able to locate survivors under debris. We have ultrasonic sensors. Ultrasonic sensors are those sensors that produce ultrasonic waves, and when the ultrasonic waves reflect back after striking a surface, then we know that the surface is present. These ultrasonic sensors are are inspired from bat technologies, and basically bat are able to navigate in darker environments without light, without eyes, with the same sense. Ultrasonic sensors, our robot is also able to detect in those difficult situations where the visibility is very low. We also have sound sensors. Sound sensors are very important because with the help of sound sensors and machine learning algorithms, we are able to detect human life and possibly navigate in that area where possible human lives or rescue agent is to be found. Combining all of these sensors, combining multiple data from the sensors. For example, we can combine the heat sensor data, the infrared sensor data, and the sound sensor data together to find the exact location of the human being, or the possible life forms, or the possible rescuing agent on this area. Data processing and AI integration is one of the most important parts of our robot design. We have utilized supervised and unsupervised learning. So basically, supervised learning are those kinds of learning in which the artificial intelligence or the learning agent, which is the artificial intelligence in this scenario, is fed with known data with results. So this is called as supervised learning. While unsupervised learning, which is particularly important in our scenario, uh, is a type of the learning in which the results are not given to the learning agent. Our system uses reinforcement learning algorithms. The reinforcement learning algorithms are useful for robots to maintain a balance. Basically, the robot contains the robot contains a polygon of stability, and if the center of gravity of the robot falls inside the polygon of the stability, the robot is balanced. In situations where those center of gravity falls outside of the polygon of stability, then in such a case we can use reinforcement learning to ensure balance of the robot. We have also made sure that those data that we receive from the environment are not false and are properly evaluated before entering inside the robotic system. Because the robot works on swarm robotics, one information that is learned by one of the parts of the robot is also transmitted to all the parts of the robot. For example, if the drone learns a certain kind of information that is applicable to both uh, submarine and the basic main body, then this knowledge is properly transmitted to all of its parts and the learning is distributed. We also have taken the consideration of the environment while constructing this robot. The environmental considerations include the robot is equipped with rock materials, protective casings to operate effectively under debris in low light situation in various weather conditions. So now we will discuss how this robot will actually communicate with the other systems like drones, how the base body will communicate with the drone, or how the base body will communicate with the submarine, and how they will integrate to communicate with the main human rescue department. So in order to do that, this system is integrated with the satellite communication and a drone communication as a support role. You can clearly see from the figure the actual communication setup that we have developed. At first, the drone in the main base body is connected to the satellite. That means these are connected to the satellite, and the communication is done through satellite communication. Then we have the drone that is connected to the submarine and the main base body with the help of radio communication. Since their range is less, we can use radio communication in this scenario. And also the main base body and the submarine is also connected through radio communications. So we have radio antennas at main body and submarine both. So as a whole, we have satellite communications and radio communications acting with an interlinked fashion in order to ensure robust communication among different robotics parts of this single robot. So for these kinds of situations, Delight, a smart pathfinding algorithm for robots in changing environment like disaster zones, is used. So Delight is a kind of a algorithm which tries to find the shortest path to reach from one point to another. Let's take a simple example where a surveillance drone finds out a person is trapped inside um, a house or a certain area or a certain node in a given graph, uh, and the robot should reach to this place as soon as possible. At first, if we use the delight algorithm, it draws an initial path. So first, it finds the shortest path from the goal to the start. So it does this so the robot always knows where it needs to go. Then real-time update is equipped. The Delight is equipped with a real-time update. Unlike other algorithms, which solely depend on the first node and to the last node, this Delight algorithm can actually change its path based on the dynamic data that it feeds. Let's say while traversing a path, the first robot experiences a certain kind of a hurdle. To remove this hurdle, to avoid this hurdle, and to again traverse to the shortest path, including that hurdle, delight algorithm works perfectly. So delight algorithm is great for helping robots navigate complex areas, adapting to new hazards while staying on the best path. The main source of power for this kind of robot is lithium polymer battery. The lithium polymer battery is generally rechargeable and it can be used for delivering high power by covering up low spaces. Similarly, the main body of the robot The main chassis of the robot is provided with solar panels. The solar panels helps for recharging the lithium polymer battery of the robot. Also, the drone is equipped with a charging feature. That means when the system runs too low on power, the drone can travel from that specified place to a desired location where charging ports are present. The drone can charge itself by itself or through human navigation, and after charging, it can transfer some of its charge to the main robot for its proper navigation and traversing in difficult terrains and lands. So, from this way, a high precision disaster rescue robot can be created. All the factors mentioned in the given video can be used and integrated in the robot for its high performance. Also, the robot should be subjected to many different kinds of conditions, uh, and its area of approach should be increased uh, in order to in order to ensure better efficiency. Since the robot is dependent on reinforcement learning, the more the robot is brought to ground and uh, exposed to such kind of situations, the more the robot becomes robust to such kind of situations. This robot will help a generation of other disaster rescue robots to develop and grow and to traverse through the challenging terrains during floods and landslides.